this is picking up with example 4 on 5-1, and what we're going to do actually is pause this for 1 second. Hold on. Okay, I'm going to get you to flip in your packet to page 3A. So ultimately just flip the page. You were, well, darn, hold on. You were here, and you're going to flip the page, and you're going to be on this page. Because before I can do example 4, I need to go back over and make sure you remember how to foil from Algebra 1. Hold on, I'm taking my scarf off. It's killing me. It's so hot in here. This was the day the power blinked, so it's hot. Remembering how to foil, and that's where you do the 6x times the 5. And you know what? Forget it. I'm going to write it all the way out. I'm going to make sure that you know how to multiply it all the way out. Okay? And then I'll show you your shortcut. You do the 6x, and then you do times the 5x plus 1. You do the 6x times everything, and then you go back and pick up the 1, and you do the 1 times everything. Alright, so you're going to do 6x times 5x. And remember that you multiply your numbers, and you add your exponents. 1 and 1 makes 2. So 6 times 5 is 30. 1x times 1x is x to the second. Okay? And then 6x times 1, that's plus 6x. And then 1 times 5x, plus 5x. And then 1 times 1. And then you combine your like terms. 6x plus 5x is 11x. You bring down the 30x squared. You bring down the plus 1. So number 2, now this was writing it all the way out. You don't have to do that each time. What you can do is you can say, I'm going to multiply the negative 3x times the negative 2x. Negative 3 times negative 2 is a positive 6. X times x is x to the second. And then the negative 3x times the negative 1 is going to be a positive 3x. And then you can go back and pick up, you've got to multiply the negative 6 times the 2x. That's going to be a positive 12x. And then negative 6 times negative 1 is a positive 6. And then you combine your like terms. The 3x and the 12x go together. So I bring down my 6x squared. 3 plus 12 is 15, and then plus 6. Now, if you remember this way and you're good at this, feel free to do this. If you have a tendency to lose signs, I'm looking to the left side of the room. If you have a tendency to lose signs or make careless mistakes, then I would do it the long way. Okay, let's look at 3. I'm just going to work it out the long way. I don't know if you've seen that before. You just take the 8x, and what happens is you write the 5x minus 6 2 times. I go back and pick up the plus 5, and then I write the 5x minus 6 again. And then I distribute. 8 times 5 is 40. X times x is x squared. 8 times negative 6 is negative 48x. 5 times 5 is 25x. 5 times negative 6 is negative 30. And then I combine the like terms. Negative 48 and positive 25 is negative 23. And then I bring down the 40x squared, and I bring down the negative 30. Okay. Now looking at 4, 4 is different. You see how that's squared right there? That means you have to write it twice. The definition of squared is write it twice. And then you're going to multiply it out. And I'll do this one like I did that one. You distribute the top. 5p times 5p is 25p squared. 5p times 6 is 30p. And then you distribute the bottom. 6 times 5p is 30p. 6 times 6 is 36. And then you combine your like terms. The 30 and the 30 is 60. I bring down the 36, I bring down the 25p squared, and then I'm done with it. Now let's go back to page 3, example 4. We're writing the quadratic functions in standard form. Now what you've got is you've got these two, you're going to have to foil them, and then you've got this 2. I want you to pretend that the 2 isn't there for a minute, and go ahead and foil these. X times x, and just for fun, turn your sound on. Because some people listen to me without sound, which ticks me off. So I've got the 2, I put it, and then I do x times x is x squared, x times 3 is 3x, negative 2 times x is negative 2x, negative 2 times 3 is negative 6. I leave the 2. I'm going to go ahead and combine my like terms. X squared, a 3 and a negative 2 is a positive 1, and then minus 6. And now I'm going to distribute my 2 to everything. 2 times x squared is 2x squared. 2 times 1x is 2x. 2 times negative 6 is negative 12. Okay, I'm going to do the same thing with the b. Okay, I'm going to go ahead and FOIL. I'm going to just leave the 1/2. Just leave it out there. I don't know why I said it like that. X times x is x squared. X times negative 4 is negative 4x. Negative 6 times x is negative 6x. Negative 6 times a negative 4. A negative times a negative is a positive. 6 times 4 is 24. Leave my half. I'm going to go ahead and combine the like terms. Negative 4 and negative 6 is negative 10 plus 24. And then I distribute the half. A half times x squared is a half x squared. A half times negative 10, and you just think of it like, what is half of 10? 5. And then half times 24, half of 24 is 12. And it's y equals, I lost my y equals. Okay, let's go ahead and do C. Alright, this one is similar to what we just did a second ago with the squared. When you see that squared means write me twice. Okay, so I bring down my negative 4. I'm going to write the x minus 7 2 times and bring down the plus 2. The negative 4 and the plus 2 are just going to stay out here. Okay, and we're going to distribute. We're going to FOIL. X times x is x squared. X times negative 7, negative 7x. Negative 7 times x, negative 7x again. Negative 7 times negative 7 plus 49. I bring down my negative 4. So that's x squared. Negative 7 and negative 7 is negative 14 plus 49. And I bring down my plus 2. Now I distribute my negative 4. Okay, order of operations says we do our parentheses first. Negative 4 times x squared is negative 4x squared. Negative 4 times negative 14, I do not know. 14, 4 times 4 times 4, 16, carry the 1, 56. So plus 56x. And negative, Lord help us, 49 times what? 4? 9 times 4 is 36, carry the 3, 4 times 4, 16 plus 3, 19. So minus 196, and then bring down the plus 2. Combine the like terms, so it's negative 4x squared plus 56x minus 194. Okay, now, if I'm not mistaken, we get to do a word problem. We do, so we're going to grab our calculator. Okay, that requires you to actually take out your calculator. So I'm going to write this. Take, for those of us who are still watching me with no sound, out your calculator. And follow along with me. You're not going to learn anything from the video if you don't watch it correctly. Why is my calculator not coming up? Hold on. I have a bunch of crap open. There it is. It's just slow. Here, I'll pause the video while I wait on it. Okay. Check me out. I have them both up here at the same time. Ooh. Okay. The path of the ball after you kicked it can be modeled by this equation, where x is the horizontal distance in feet and y is the height in feet of the ball. What was the height of the ball at its highest point? How many feet had the ball traveled horizontally at this height? Okay, so what we've got is we want to go to our calculator. We want to, here, I'll pretend like it just turned on. I turn it on. I go to y equals. I clear out what's there, and I type in negative 0.1 x squared plus 4x, and I hit graph. Okay, now what happens is you can see it going up, but you can't see it going back down, because if you think about a ball, it's going to look like this. Okay, it's going to go up. Here you are. You're going to kick it. You don't have any joints. You're sitting on your butt. Just pretend. You kick the ball, and here it goes. Woo! And then it's going to land. Okay? So what we're going to do is we're going to change our window. So I want you to hit the window button. And what this is while you're looking at your calculator screen, wow, this is your x and this is your y. This is your x max, this is your y max, this is your x min, and this is your y min. Okay? Max means highest, min means lowest, max means highest, min means lowest. So if we look at our graph, we want it to go up in the air and come back down. So go back to your window. Negative 10 is okay. Okay. It looks like it started about 0, so let's just watch what happens when we change it to negative 2. Okay, it changed to my x min, so my window cut off over there. My x max, it doesn't look like it's come back down yet, so let's change it to like 50. Could you kick a ball 50 feet? I guess so, I don't know. And let's see what happened to it. Okay, look, I can see it going up, but I see it coming back down, but I can't see it at its highest point. So now what am I going to change? Well, I changed my x min and my x max, so now I'm doing this. So I want to change my y max. So let's change it to like 50, and I'm just guessing. And that's perfect. So what I have is this, it's called a parabola. We've already talked about that. And I want to find the highest point. So the highest point is going to be right here. It's going to be the vertex. Okay? I could fill it into negative b over 2a, but I'm going to let my calculator find it for me on these word problems. So what you're going to do is you're going to hit second trace, and you're going to go down to what we're looking at is a minimum and a maximum. The maximum is your highest point. So you're going to go second trace, maximum. I don't know why I keep saying trace, like I'm from Packlet. So second trace, I've already hit it one time, I forgot. Maximum, number 4. Okay. It asks you for this left bound. All you want to do for the left bound is come over here to the left of what you're looking for. And you go, so I'm just going to take some blinky bug, I'm going to put him over here.
Good afternoon. Here are today's afternoon announcements.
Let me pause during the announcements. Longest announcements ever. If you notice the time, it took like 4 minutes for those announcements. Anyway, left bound, and then you hit enter, and it asks you for the right bound. So you just move your blinky bug over to the right side, and you hit enter. Okay. Then it asks you for a guess. I got news for you. It don't matter what you guess. It don't care what you guess. Just hit enter. And it gives you the maximum is 2040. So it's 2040. Okay. So let's see. What was the height of the ball at its highest point? And that's over 20, up 40. So the height was 40. And that's feet. And how many feet had the ball traveled horizontally at this height? 20. 20 feet. Okay. Alright, suppose a group of high school students conduct an experiment to determine the number of hours of study that leads to the highest score. The exam score for each student who studied for 8 hours can be modeled, and that's supposed to be squared, not times 2 squared. Which amount of studying produced the highest score on the exam? What is the highest score the model predicts? So all it wants us to do is graph it and find the max. So negative 0.853x squared plus 17.48x plus 6.923. Now I'm going to graph it. I'm not going to change my window any. Ooh, it didn't go up high enough.
Everyone else you all just missed. Have a station Tyranny.
Go away, Mr.
Jerry Miller, please report to the
Shh. Okay. So look what you got. Now what are we going to have to change? We're going to have to change our window. And let's change it. Our y is not high enough. Our x looks good. But let's change our y to 100. And I want you to think about why I'm changing it to 100. Because what's the highest score on an exam that you can get? 100. So it's not going to be bigger than 100. So I need to do I'm going to hit second trace. I want to find the maximum, number 4. It asks me for my left bound. So I'm going to take my bug move it to the left, right there, hit enter, move it to the right, hit enter, guess, it doesn't matter, and it says it's 10.25, comma, 96.47. Wow. Alright, so the amount of which amount of studying produces the highest score on the exam? That's going to be 10.25 hours. Good night. And then what is the highest score? 96.47. So that's the highest score. Okay, and that's the hours. Last one, is it? No, yeah, this last one. Path of a ball thrown by a baseball player forms a parabola with an equation that, where x is the horizontal distance in feet of the ball from the player and y is the height, gosh, I can't speak, in the feet of the ball. How far does the ball travel before it again reaches the same height from which it was thrown? Okay, so let's graph it. -3 over 2401, parentheses, x minus 49 squared plus 8.5. Let me hit graph. Yeah. Not helpful. What did I just do? Did I forget to square it? Yep. Nope. No, I didn't. I'm going to have to change my window. Let's hit zoom 6. 6 is the fix. It just kind of fixes it back to where it was. I'm going to need to go over 49 and up 8.5 because it moved right 49 up 8.5, so I'm going to have to change my window. Let's change our x max to 100. And everything else the same. Okay. So I'm going to need to keep going on my window. Let's change it to 200. There we go. Yay! Now it looks good. And yeah, it is just guess and check on finding the window. So how far does the ball travel before it again reaches the same height from which it was thrown? Well, how do we find the height from which it was thrown? Well, when you threw it, okay, here, picture it up right there. How high did we start? Well, how do we find that value? We hit second, trace, and I want a value. A value when x is what? Well, x is 0 there because that's my starting point. When I started, it was 5.5 foot, which should make sense. So it was 5.5 foot to begin with. Okay. How do I find where it crosses 5.5 foot again? Well, I can graph y equals 5.5. And that will allow me to see where it came back through 5.5. So I'm going to hit second, trace, and do you remember that we found intersections, number 5. First curve, enter, second curve, enter, guess, enter, 98 and 5.5. So how far does the ball travel? 98 feet. How high was the ball at its highest point? 8.5. Okay, and you don't know how I got that. Hit second, trace. You want the maximum, which is number 4. Left bound. Right bound. Enter, guess, enter. 48.9997 and 8.5. So that's actually, that would round to 49 and 8.5. So how high was the ball at its 8.5? And that's 8.5 feet. And the reason I knew that without doing it is because it was in vertex form, x minus h squared plus k, where this is how much it moved up, this is how far it moved over, and it was opening down. The end.